Thanks for braving the elements. This is now a reminder for me why not to schedule meetups in the middle of winter. Our last one was during the polar vortex, and very few people braved the cold, but those who did had a phenomenal time. So hopefully tonight will be another great event, and I say thank you to Dekus for coming tonight to talk us through Screwdriver.cd. I say thank everybody else for coming as well. Just to tell you a little bit about Shopkeep. Shopkeep is a tablet-to-cloud point-of-sale solution. But I'm not here to talk to you about Shopkeep. I just want to mention a little bit about our commitment to the community. Shopkeep is firmly committed to helping every community in which we operate. And as technologists, the community in which we operate is you guys. We learn from each other. You learn from others as well. And so if you've got a technology story to tell, we'd love to help you tell it.
All right. Hello. Thank you for coming. In this horrible NYC weather, I know it's going to be tough. Nose and rain together. So this talk is about Screwdriver. That icon is actually off a little bit. Anyway, so Screwdriver is the de facto CI/CD platform that we use and we deploy at Verizon Media. For those of you who don't know what Verizon Media is basically it's a subsidiary company under Verizon, which is our parent umbrella company, and Verizon Media basically is serving Verizon is whole digital platform. And before the name Verizon Media, we were previously known as a company Oath, and it was a merger between AOL and Yahoo back in 2017, if I remember correctly. And so basically, we have like a bunch of brands from Yahoo, like Yahoo Sports, Finance, Homepage, News, Media, and also something from AOL, like the ads platform, like Huffington Post and stuff like that. So as you can imagine, the scalability issues gonna become one of the major factor to dealing with many like tens of thousands of bills every single day, and also like you have different target platforms such as like mobile platform, media platform, publishing product platform, and also among those platforms you have like different like teams who are like very sophisticated in like their own technology. For example, some of them like very sophisticated in Java platform. They build a lot of projects with Java, and obviously not to mention the ML, AI stuff. So Screwdriver is the platform that underneath Verizon Media that doing all those like CI/CD stuff. So just a little bit about myself. I am Dekus Lam, and as you can see here, my avatar actually is Rick Sanchez. Any Rick and Morty fans here tonight? Raise your hand. Awesome. Probably someone who around my age, probably a big fan. So I'm Dekus Lam. I am currently a developer advocate at Verizon Media. So I have worked on like number of projects that's kind of like span different stacks. But only recently I got pulled involved into this Screwdriver project. I think I joined Screwdriver team back in like October last year. So I'm like kind of like new to the team. And the whole I think the current number of members, they mostly like located in Sunnyvale. So we kind of like do like a daily stand up about everything about ongoing agile practice, stand up and stuff like that. And yeah, so the agenda for tonight is like first of all, I'm going to go over some background and history about Screwdriver. And then afterward, we're going to go over some like high-level overview about Screwdriver by using its workflow. And then after that, I'm going to dig a little deeper into this architecture. And toward the end, hopefully I'm able to cover some current status of Screwdriver, the features that it offers to users. And then after that, we'll do a little demo. Like I mentioned before, it's the CI/CD platform at Verizon Media today. With all the brands and everything, with all the new projects going on, the average number of like daily bills per day is like over like 30K, and which corresponding to almost like 30K pipelines. Pipeline in this case here refer to like a particular project or kind of like a repo, if you may. And then for templates, I'm gonna explain about like what templates later. but as like in, like as you can imagine, we have like different platform and different languages like Java, Go, and then like C++, and then Node.js and stuff like that. So we have like very strong presence of different programming languages within the company. So we need to offload our best practices about different languages to those particular like language expert. Because obviously, one platform cannot maintain everything. There's no one solution that fits all. So we have to delegate to different, domain expert to handle their, defined workflow for the particular jobs. And so under history here, you see the version 4. So the current version of Screwdriver, which is open source, by the way, is the fourth generation, the fourth iteration of Screwdriver on platform. When I first joined Yahoo back in 2013, the Screwdriver platform that I knew of at the time was basically, it's like a Jenkins wrappers. So it's like it definitely have some sort of internal proprietary software running on the Jenkins slaves. I think it's some sort of some sort of internal tool that implemented on top of chroot to create like a virtual host environment so that your build is actually running in like a isolated environment so that they don't get breakout. And then the second version that I know of, it was during the time when Docker became very prominent, and you start to see like containers everywhere, almost like literally everywhere. And then the platform evolved into more like container-driven approach, where instead of like individual like chroot based built environment, it actually see a container. So obviously there's a lot of security around like container breakage, breakout, escape stuff. The platform itself actually has some like dedicated software to actually able to enable that. That never happened. So what Screwdriver does the best is basically it's actually enable the whole automatic continuous delivery, continuous integration for your pipeline. So like whenever like you have like a PR open or you merge in a commit into your master branch, the magic start happen, and then so basically is everything just come down to one single file that's called Screwdriver.yaml file, and that's the file that sort of you have to that you use to declare the definition for your jobs. Like in this particular case here, sorry for the little size there, but in this particular example here, you're running a jobs that basically just do some sort of basically NPM stuff like testing and then build and publish and stuff, and then you see some keywords here like image, like requires. Those are like little reserved keyword under Screwdriver YAML that kind of works out the magic, but under the hood it's still going to be a container to run your build at, and then. Screwdriver currently within Verizon Media is deployed to both on-prem data center as well as AWS. And Screwdriver is actually built on a plugin system. Obviously, why plugin system? Because like first of all, it's open source. It's easier to get contributions from the community. And the current plugin system works like this. So in terms of databases, right, you can choose like Postgres or MySQL or whatsoever that able confined to the SQL interfaces. And then for data store, if I remember correctly, you can choose like in-memory or S3, and data store is used for something like your build artifactory that there's something that you generated. Like a tarball file or something that you generate on your build, and then you want to preserve it so that you can push it to some sort of like online external like data storage. And then for the executor is something is like an intermediate layer between the Screwdriver API layer and your actual build. So for the current executor plugins that we provide out of the box, we have Docker, we have Kubernetes, and then we have like Kubernetes with a VM, and that VM actually is initiated and created by something called the Hybrid Container. from the company called Hyper.sh, which is currently part of the Color Container like initiative kind of thing. So the reason why we have the VM one as a plugin is because like we care about security. We take security very seriously, and in order for us to avoid those like shared kernel or potential container like breakage or breakout, so that's the plugin that actually we deploy to our internal data center, and the one we deploy for the open source is actually just the Kubernetes itself, because like it's running on AWS, and as you know that if you want to have like a VM as part of your like Kubernetes pod, it's kind of like like you create a VM and then that create a pod for you. You need something called the nested virtualization technology, which is like kind of equivalent to like QEMU, like simulation, but in AWS, you need to have something like i3 Metal like instance type, which is very expensive. So probably not suggested you do that. And I think for Google Cloud, they have something very similar, but I think they have like very sophisticated limitation on that. Like you cannot create instances with certain like VM with like certain CPU architecture. So with that being said, so we use that for our internal clusters, and then we use the Kubernetes one for the external open source one. So okay, so this is a workflow diagram of like a typical build lifecycle within Screwdriver. So first of all, like I said before, you have a PR open or you merge and commit into a branch or master whatsoever, and then the API, Screwdriver API, will get that notification from the webhook that we install in your repo. Obviously, you have to grant our permission to our Screwdriver bot for you first, and then once that kicked off, your Screwdriver YAML would give us all the configuration setting, like annotation stuff to the API, and API will compose like a job configuration, and that's sent off to your internal execution engine. Here, the engine consists of the launcher, and the launcher basically is you can think of it like a software or binary software that a CRL tool that actually able to spawn like a shell session or something equivalent as like a environment, so that your whatever steps that you define in your job in your Screwdriver YAML will be run within, and then as your build like start processing stuff, all the logs are forwarded by another external like services, something called a log service, and then we actually log that to your data store, which is the one that you have options over, like to choose it S3 or something like that. And then after your build completes, and your those artifacts would also be pushed to your data store of your choice. At the same time, by the time it completes, there could be something like a build cache. I'm going to explain that later, but build cache basically, as the name implies, is about caching stuff. So you could have like npm. I mean, we all know that npm consumes a lot of like disk space, because like it has like a very nested dependency tree of everything. So one way to increase the speed and performance on your build is to cache that npm cache or npm local node_modules directory. Assuming that you're like doing like package JSON log file and stuff like that, like YARN log file. So there are some key components to of Screwdriver. First of all is the UI layer here. So that's like your entry point to all your pipelines and every details. And the UI is actually a single page Ember.js application. It's authenticated through, I think it's authenticated to your CM, like GitHub, GitLab, Bitbucket, using OAuth, and then it actually communicate internally with API via JWT, JSON Web Token. And then the API layer here is also a Node.js application, but the framework that we use is actually called Happy, which is something from Walmart Lab. they kind of like a conventional framework, unlike other like Koa and Express, where you kind of define everything yourself. In Happy, actually, I think the reason why we chose Happy at the first place is like it's conventional. So a lot of things you're able to like with very minimum amount of code, you're able to get the server running. I guess that's the reason. And then the next layer is the execution engine, which is like this whole thing here. As you can see here, there's like something called a scheduler, something called executor queue. So whenever your build start to bootstrap and the API recognize there's like valid build going on, and about initiated, and it will create a job object to push to the job queue. And in this case, the job queue is actually backed by Redis, and then the executor queue is actually a little piece of software that sort of just spit to that queue. So as you can imagine, it's kind of like how SQS works. You're just pushing stuff to it, and then you just pull it from the other end. And so as you can see here, if as the number of builds got accumulated into the queue, and there's something called the queue worker here to pull from the queue, and that's the one piece of software is gonna like analyze or parse your job configuration to understand like, okay, you're like you're about to start a build, and this is your declaration for your base image. For example, for Node.js application, you want to do like Node, maybe version 8 or 10. In this case, it will figure it out that's base image, and then all your configuration for your steps afterward. And after that, it's sent on to the next stage, which is the launcher. In this case, in this particular example, is marked as Kubernetes. But it works pretty much the same thing. It was just Docker Swarm or something like that, because like by the end of the day, it's going to be a container being spawned corresponding to your build request. And so the launcher here is after the queue worker pulled the job from the queue, it would initiate a queue worker. So queue worker is something that you're able to choose. Like I mentioned before, it's a plugin, so you can choose Docker, you can choose like Jenkins, something like that. And then in this case, Kubernetes, so it would create, it would know how to create a pod, a ephemeral pod, so that it knows how to create in the containers. You know how to, like what containers run on, which is going to be the whatever base image that you define in your configuration in your Screwdriver YAML file, and that gonna be that will spin up a pod, and then the pod will basically just run through whatever command that was like indicated by the launcher. Basically, your all the steps in your job, and after that, you push whatever artifacts that you generated to a store. In this case, S3, and obviously, if you are going to build like microservices, you're gonna have like a lot of Docker images being published at one step. So you could also have a chance to send that to your Docker registry of choice, or are you building something like like RPM or even like Go binary that you could put you could push something like to Artifactory like JFrog Artifactory, and obviously you can also send it to different endpoints. For example, like for some ML build pipeline, they just send their like like machine learning model to like S3. So the current status of Screwdriver, these are the list of key features that we currently offer. SonarQube, so this is like the one that I would say very popular right now throughout the community for code quality check. It covers a lot of like language and everything. So the way it works, like we have our internal SonarQube deployment on the same clusters as your build, so that whenever you obviously you have to configure something on your Screwdriver YAML file to enable it, and then after you enable it, and then you also have the option to define your own like properties or profile for your SonarQube, and then we will take that in and honor that and run that along with your build as part of your step. And then the result will publish back to the UI of the Screwdriver. So when you click on the build result page, you will see like a little like coverage or something like that on one of the part of the page. External configuration. So this is for the case where you have like a hierarchy of pipelines. For example, you could have like parent pipelines that have two children pipeline, and those two children pipeline is like slightly doing different thing, but they rely on the same configuration for the parents. And let's say when your child pipeline is running a build, and it can also reference the actual like the parent source code inside this build as well. So which is kind of nice when it works when it is working hand in hand with MonoRepo. So I know a lot of like practice these days, like there's like projects like Learner, there's other projects like with Apache, they're like Think Post or something like that, and they have like a practice of MonoRepo. Basically, you have single repo where you have like a folders consisting of like many different like mini packages. NPM is definitely, I mean, Node package is like one of the big, like consumer of MonoRepo. Like Facebook do a lot of things in MonoRepo. So in order to fulfill that request, we have something called the source path. So source path, kind of like as the name implies, is like so in your Screwdriver YAML file in your job, you can specify like an array of paths. So whenever there's a code changes happen within that path, that job will get notified and trigger. So your build would kickstart like that. And so that's pretty useful when you have like I said, a MonoRepo or like microservices in one single repo, and everything is like on its own like subdirectory. That works gonna be they're gonna be like very good. And then the fourth one is branch filtering. So it's basically to put into simple term, it's just like regex that sort of like matching against the branch where your code is committed to. So I know a lot of people like they like to have. They're not just gonna have like master branch and then PR and stuff like that. They usually have like a PR and then into like a feature branch, a feature for like something like a feature 1, feature 2, and then you only want some job to trigger based on that branch. So that's the way to go with branch filtering. So that you don't have to like, oh, now I have to create like a pipeline for different like branch, like one for master, one for features. That's not gonna happen because you're able to do so with branch filtering. That saves you a lot of time. And then advanced pipeline workflow, that's something, I would say that's something is quite useful only if when you have like very sophisticated, complicated like workflow. So for example, like just to use that example from earlier on, like microservices or MonoRepos and stuff. Let's say you have like a single job, right? That sort of do like a linting across and stuff, and then afterward you want to fan out to each individual job with each individual build targets per se, and then after each individual job's done, which is happening in parallel, and then you want to able to like aggregate all the artifacts or like result of those jobs, fan into the next round, which is the next job. And for example, in this job, you could do like a final check on things or you could do like functional testing against those fresh and new built packages. And that way you can able to do a lot of stuff. And then sometimes you have like a cron job or periodic build that you want to kickstart without any sort of human intervention. And that way we also able to support that by specifying that in a annotation property under that Screwdriver YAML file. And then for the next one is build cache. Like I mentioned before, it's basically just a cache corresponding to whatever path that you define in your Screwdriver YAML file. So in this case, right, you could have the cache set at different level. The first one is the pipeline level. So the pipeline is like your entire repo, and not whatever like PR, whatever commit that being merged into that particular branch or master, they all share the same pipeline. So in this case, the cache can be set on that pipeline level. So every job that run, regardless of whatever event it's coming from, is able to retrieve that cache from that pipeline level. The second level is the event level that only persists throughout your event. In this case, could be like a commit merge. The last level is job level. So whatever that you have a job that's gonna run again, so it will able to retrieve the previously set cache for the next run. So that like in this case, for example, like npm build, you can npm install, then you can able to just retrieve that cache from npm and also the local no_modules directory. And then the second and the eighth one is grayed out because it's currently working on its upcoming features. Build clusters, it basically translates to bring your own clusters. So in a multi-tenant world, Screwdriver is actually able to foresee that, okay, there's a need for a multi-tenancy in the whole platform cluster because, for example, right, we talked earlier about like there are like different teams. You have like a Java backend teams working on something, and then obviously you have like a mobile application teams working on iOS build, Android build, and we know that there are different hardware needs from different platforms. For example, you might need a racks of Mac Minis just to do those like Mac virtualization and to perform the Android or iOS build. So in this case, you can onboard a new build cluster onto Screwdriver. Either you can allow Screwdriver to handle it for you or maintain it for you, or you can just say, I want to onboard this, but I want to maintain it myself. And that's the way how build cluster work. So on a high level, in terms of like technical changes, if you're gonna onboard a build cluster to it, the only thing gonna change there is gonna be here on the right side, Redis and QWorker. The only thing gonna change is the QWorker. So QWorker, like I said earlier, it's just gonna pull the job from the queue from Redis. So in this case, once you onboard a build clusters, it's gonna be another queue on top of this. So the QWorker here is going to become the new master QWorker. So its job is to assign and schedule the job from the original queue and assign to the queue in your own clusters. In this case, could be like iOS build. So that way you can able to make sure your job are prioritized on particular hardwares. Another example will be like ML machine learning stuff, right? There's like often the cases where some machine learning job, bash job, they need like a very extensive, very massive computing powers, like or even require like GPU instances, and also like very large storage as well. So in that case, you can, if you're able to secure yourself a clusters of resources on your own team, then you're able to onboard that to Screwdriver so that you don't have to worry about the CI/CD part of it. So back to this, the build metric is basically like the metrics around your build performance. So it's since it's upcoming features, so it's going to be providing you insight into how performance your builds are. For example, like how long it run, how long it take for like pulling down from the cache, how long it's going to be for it to publish its artifacts to the whatever data storage that you have defined in your clusters. And all that metrics and statistics going to be available to you guys very soon. So currently Screwdriver has two main collaborators. One is obviously us, Verizon Media, and we have a team dedicated to do this. And then the other major collaborator is Yahoo Japan. It's also from Yahoo, but it's like slightly different because they like kind of like a independent entity in Japan, so it's not like affiliated with like Yahoo US anymore, I guess. And they have like several like engineers. They actually deployed Screwdriver in their own clusters, I think last year, and they have been working with us, together like ever since. And they have like tackled several like issues around like APIs layer multiple times, and they should able to contribute to different features that people requested in the community and also requested by them. So in terms of like the features that we currently have, we have like slightly over 100 feature requests right now on our GitHub. And obviously, we need more community support, and feel free to try it out, and PRs are very welcome. All right, that's it for me. Any question before we go on to the demo? Go ahead. There's a mic.
Sorry. I have a question about monorepo support. I think this is very interesting and it's very unique.
Mm-hmm.
I don't think that there are lots of continuous integration servers which have support for monorepo. You hear me?
For notebook? Was that notebook?
Yes,
Support for what? I'm
can
sorry?
you explain more about the monorepo support?
Monorepo support. Oh, okay, monorepo support. Okay. I think right now there are two major paradigms. One is you do it on your own, on your repo level. One is like let the CI/CD handle it. I'm not sure about like other CI/CD out there, like for example like Circle CI or like GitLab, whether they actually able to do that like natively. But by the end of the day, it's going to be you have a like root directory, and then you have a subdirectory with all the packages in there, and either you install something, for example, like I'm a big fan of like npm and Node.js community, so there's something called Learner, and a Learner is something like a monorepo CLI tool that lets you sort of like figure out all the dependency across your packages and stuff like that, and they also it also offer like a CLI option for you to sort of like run those publish together, individually inside a monorepo. Or you can do it like what I said before about Screwdriver, where you have different jobs, and then you have a dedicated path for that job. So in this case, you can have like a job for building like a video services in one of the directory in your source code. In this case, for example, and then you can have another directory doing like totally different thing. And then the only difference is like you have to specify another path for that particular services in this case. So it's kind of like it's all come down to like matching a path to the actual like directory you're hosting the source code, and then in your build you can able to create like a for example, since the whole config is in YAML, so you actually create something like YAML anchor so that you don't have to like repeat yourself again and again. So that way you can do it, or you can like do like create like a template. So template in this case, like you can like abstract all those like predefined stuff like environment variables or like the base image into like a particular template, so that your actual job configuration can actually extend from it. And in that way, you can able to let's say I have a job for video, a job for weather, a job for news and stuff like that. So for each individual service, you can able to extend from this template, and let's assume that all of them are Java applications. So that template also, let's say that template is also on Java, so that by referencing that template in each of your individual job in your configuration file, you're able to save all those like typing and everything, and then and during the build, everything's just gonna run according to whatever defined in the templates. So that's like our take on monorepo support. Thank you very much. Any question?
Since you mentioned templates, how do you safely make a change to a template?
The question is like, how do we safely make a change of template? So, okay, there's two phases about template support from Screwdriver. We have already completed the first phase, which is like basically the whole template creation part, and inside the process of creating template, there's a part called validations. That's really basically at your disposal. You can define whatever stuff that validate against your template to make sure it's valid. And then the second phase is upcoming, that we're actually gonna like implement something called the trusted namespace for templates. So for example, only a certain trusted source of templates are recommended for your pipeline. For example, if template is gonna be if everybody gonna start publishing templates, so how do you guarantee like which one like is the go-to one, which one is like the one in like Wild West, right? So we actually going to implement this, and probably I would say it's gonna based on community like ratings, like stars, something like that. Sorry, do I answer your question like that?
Yeah, partially. I mean, I'll phrase it more specifically. So one of the benefits of having parents or templates or however you implement that is that you can have like thousands of teams use one base configuration.
Yeah.
The flip side of that ability is if you make a change to the base configuration, you can break 1,000 teams in one go.
Okay.
So
Obviously,
How do you prevent that?
every published template is actually tagged by version. So if the maintainer or platform owner of that template is going to publish like a breaking change, I mean, he better bump the major, man. I mean, obviously there's no guarantee on that, but as the owner of that, you have that responsibility to do that. And if all of a sudden everybody's build is failing because of a single change in the template, we have notification about your build. So once that come up in your Slack channel or your email, we note it immediately. And obviously, after, I mean, I'm going to do a demo later, but I mean, you can tell like what's going on inside your build. Sorry, the log for your build, so you're able to find out like what's going on about like whether something is actually from the template or something from your own source code.
So just to clarify, I think you said it, you don't depend on a template generally, you depend on a version of the template.
It's better to have a pinned version.
Okay.
So what would be some recommended prerequisites for organizations operationally if they were going to think about using Screwdriver?
Sorry, I missed the second part.
Like just some basic operational processes that companies would need to have in place if they were going to consider using a software like this.
Okay. I would say the only thing that you need, I would say it's best recommended to have a existing Kubernetes clusters. That's like the lowest common denominator, I would say, for now. And I'm going to show you like a repo afterward. We have like some existing deployment, deployment boilerplate that you actually to play with. And I think it's actually a Helm chart that deploy several services like the API, UI, and also like backend layer to the to your clusters. Does that answer your questions?
Yeah.
Obviously, that's like the prerequisite for your tech stack. But I would say like it's really up to you whether you're going to have a hybrid cloud or private cloud or public cloud, or you're going to have like deployed onto your data center. So in our case, we deploy to our own data center, but we have a bunch of folks who actually have to maintain each individual like kube nodes and like make sure everything is run correctly, especially runtime, especially what happened like yesterday about the container run C exploit. Anybody know about it? Right, raise your hand if you know about the news. All right, cool. You should have known about it already. And yeah, I mean, there's like over the last several years, there's been a number of container escape exploit happen around containers. So I would say, like I mentioned before, it really depends on your environment where you want to deploy Screwdriver to. Like I mentioned before, if you're on AWS, we have the open source clusters on AWS, and we are not able to run the one with the VM in there because of the hardware issues that we have. Sorry, because of the easy to issue issues that we have there. Just cost. It's very costly to have that particular instance type so that everything works with the VM. There's like another thing that I recently read about, something called the Amazon Firecracker, which is like an Amazon take on the whole micro VM thing, right? And things like once that able to support Docker or even Container container like natively, then we able to have like a different like approach to that kind of like CI/CD platform on that level. But if you are deploying to your data center, like I said before, you have to make sure every node is compliant, and obviously it has to be a Kubernetes. That's that's this downside of the thing. Otherwise, you will have something like a Docker Swarm, which works as one of the plugins. But obviously, if you have Docker Swarm, you might as well just go ahead and upgrade it to Kubernetes. Any more questions? There's one over here.
I actually have two questions. One is going to tag back on the templating stuff. Is the templating stuff like a data store where you're just kind of like manually doing versioning, or is it actually like in Git somewhere where you can reference a shellcode, or is it like a Docker container?
Okay, good question. Like I mentioned before, right, all your jobs are in a Screwdriver YAML file. But if you're going to deploy like a template, you have another YAML file that corresponds to that template. And inside the template, you define everything, like how your template is based on, the step, everything. And once you create a pipeline for that template, so kind of like a individual pipeline, and then we would know that you are going to build a template. So we will automatically tag your template based on the version that in that particular YAML file.
Okay, so you're manually like internally handling
like
that.
auto
in the
increment,
data
I would
store.
say, until you bump the major.
Okay, cool.
So,
and
yeah.
second question is, I'm assuming obviously like Verizon Media is using Screwdriver and whatnot. Like, who are like some other folks that use like
Right.
Screwdriver?
So I talked to my colleagues about this question before. Like I mentioned before, Yahoo Japan is the other main collaborator and also consumer of Screwdriver. They deploy to their own clusters. I'm not able to disclose how many built they run, but I would say it's not less than Verizon Media. And the other like companies or like I wouldn't say enterprise, but entities out there that I know from my colleagues is like there are other like startups that are actually looking at it right now. I'm not really sure about the detail, but they have appeared and to ask question about like how do we gonna set up Screwdriver, how the whole thing's work, and more detail and docs and like that in our actually Slack channel, which is in this slide here. Here we have like the first one is like our documentation, and the second ones are our GitHub link, and then the third one, which is the one that I'm going to demo later, and then the API docs are like I think it's like a Swagger UI thing, and then contributing about PRs and stuff like that, and that's a Slack channel at the bottom. Yeah, so those are I think I wouldn't say it's quite popular, but I would say there's some like community support ongoing. So I mean, it really is up to you guys whether you want to try it out, give you some feedback to improve it. Thank you. All right. So I'm just gonna go on and do some demo to show you what Screwdriver is. Okay. Sorry for the fonts. Maybe I can just zoom in a little bit. Oops, that's too much. Okay, this is like this is our actual Screwdriver API core project, and this is the Screwdriver YAML that I've been talking about. And there are some syntax you may be very familiar with that syntax in very similar way from other like CI platform out there, but it's YAML, so I mean, it's pretty much the same thing. The base image here basically dictates like what is the actual image that the launcher, which I explained before, is going to create your container, create a build container based on. And then these are the jobs. This tutor thing here, tutor PR and tutor commit, those are the two predefined, I would say, identifier for signaling whether it's a PR or whether it's a commit from a particular branch. And then the steps here are your actual like shell script whatsoever command line like construction. And then secrets is like I'm gonna show you later, but basically it's like your token credential that you store inside Screwdriver, which we never gonna review. And these are pretty much similar stuff. Environment here is basically just like overriding the environment that got passed into the container that launched by the launcher, and also with the secrets. And then these are different here. Beta is actually requiring publish. So basically, it's like a workflow here. It's like, oh, A require B, B require C, something like that. And these are the regular, instruction. Yep.
Each of those jobs needs to clone the repo again.
No.
But it does say set up CI each job.
Oh, sorry, my bad. It does have to get pulled from the whatever repo that you defined. But we only pull up to a certain history, so it's not like we're gonna pull your entire Git tree. So that's the way that we would do it.
No, I mean, I guess the question is There's no workspace
like-
which is
you mean like-
shared
you mean like here?
across these. Yeah.
Oh, that just happened to be that this particular job here, they want to use some sort of like shell script from this particular repo. So
Oh, this is from a different repo. Okay, we're cloning.
So
some more
obviously,
stuff. Yeah,
if
yeah.
you want to make this into the template, you
Mhm.
will include it in your template, and
Okay.
so that you don't have to do it again. But in this case here, I think the author want to go for redundancy. Yep, and that's the yep.
Quick question. At the top, right, it's saying essentially, I'm assuming that that's saying it's on a PR and a commit. So essentially, if you're committing to like whatever that branch is, and on a PR into that repo, it's going to run the build.
Mm-hmm.
Is that like applicable to like essentially the entire downstream?
PR right now. So there is a so for commit is going to be the entire workflow. So whatever being connected in one node to another, it would go from start to finish. So PR is only right now is only respond to whatever job that require it as a explicit direct dependency. So in this case, this particular main job here, if you have a PR that you created, main is the only job that's being run. So we the Yahoo Japan team is actually working on a like a PR chain of workflow corresponding to, because like obviously you definitely want to run more than one job for some PR. Let's say you're changing some core dependency or core like configuration and saying you don't want to monitor the whole thing like as a whole. You don't want to be just
So that piece is like it's kind of assuming how that works behind the scenes.
yeah.
Like what a PR versus.
Mm-hmm. But so basically for PR, it's gonna be the one, whatever that directly requires it, and then for commit will be the whole flow. Okay, and okay, let's go on to the next one here. So this is the dashboard of Screwdriver. Sorry about the font size. These are the these are the collections that I collected. Basically, you're looking at my dashboard right now. So once you let's see. So once you click on one of these guys, let's say the last one here, this is the pipeline page for the report that I just showed you here, and these are the job that was like that is like defined in your Screwdriver YAML in that particular repository, and then you have event and pull request on the right rail, and then all those like build status are updated on real time, and then like view. Like let's say you have different like events triggered before, like based on the commit, and you can actually able to go back in history and look at like all of those. And then, for example, you have the aggregated view here, which is like basically aggregate all the previous event in your pipeline, so that it gives you like a aggregation, aggregated states of your health of your pipeline at the moment. And then if you actually go into it, I think, no, not this one. Let's go to publish, or maybe like this one. So we're going to a build, and these are the steps that you define in your, let me find. These are the steps that you saw in the Screwdriver YAML file, and every one of them will have a corresponding logs for that particular steps. And on the bottom left here, these are the artifacts that you happen to generate it, or those that are generated by the Screwdriver platform itself. And then to answer some of the questions about the Git pull before, let's see. So this is the actual the setup of the whole repository. In this case, GitHub. It just running a bunch of like git command to pull it down based on certain like depth. In 6 is like 50, I think. So, yeah, in this case, only clone up to 50 in the history, and these are the all like pre-init like step of Screwdriver during the setup. And then there's like something called tear down. Like for example, you can define your own tear down step. For example, where you have like a where you're like, for example, you created some sort of intermediary objects or files as part of your build pipeline, and you want to like remove them no matter something fail or not within your build lifecycle, and you can able to define something like a tear down step, custom tear down step yourself, and then it will run no matter what. And in other cases, like for example, if you like say consume some sort of API, you want to like kind of like let's say you mock some API, you want to like revert it. That's one way. That's the part where you want to find that. And these are the particular artifacts that was generated based on your pipeline. Okay, let's go here. So these are the templates that I mentioned before. Right now is community based, so whoever that have access to this particular Screwdriver cluster platform here is able to publish a template. So let's go into one. So to answer the question earlier about in case somebody break a template, there's a versions of tag, and there are also floating tag about stable, latest, and I think like there's stable and latest, and maybe one more, I think like current, something like that. But I think stable and latest should be good enough. And obviously, as the maintainer of this platform, as the maintainer of this template, you should be very smart with the floating tag. So make sure if people are gonna run your template with stable, you make sure that's stable. Okay, and so I want to mention about this at the last part of this presentation is the command. So command is pretty much like the template, but it's at a very like smaller scale. So template is about your whole pipeline. So basically, you can have your whole job just extend from a single template, and then you do nothing about it, and the whole thing will just run as it is. But for command is something is for something like very small. For example, like a instruction, or even like a consolidations of instruction. Let's say, for example, you can have like a command just do like, let me set up my source lab connection so that I can able to tunnel it to I can able to let source of the tunnel it to my whatever testing server so that I can run my functional test against it via that tunnel with source lab, so that you can actually able to define something like this as a shared command, so that when somebody else have like a like repo project, they want to do the same thing with unit testing or functional testing, they don't have to re-implement it themselves. They just have to like borrow this shared command and just run it directly in as part of their steps in the job. So the way you do this, like something called SD command CLI tool, and then you exec, and then the namespace and the name of the command and the version, and that will automatically bootstrap itself into instructions. All right, I think that's it for my demo. Thank you very much.
Well, everybody, thanks for coming. See you at our next meetup. And like I said, if you have any war stories that you'd like to tell about continuous delivery, come talk to me either through Meetup or through email directly. And thanks everybody for coming and braving the weather. Have a good night.
Have a good night.